Hello, my name is Professor Martin Were. I'm an associate professor of medicine and biomedical informatics at Vanderbilt University Medical Center. Thank you for participating in the DSI Africa Symposium. We also want to appreciate you for taking the time to join our discussion around training the next generation of leaders in data science and health innovation in Africa. My name's Martin Were, and I'll serve as the moderator for our discussion once we get to the in-person panel. Let me start by introducing myself. I'm an associate professor of medicine and biomedical informatics at Vanderbilt University Medical Center in the US. I'm also the founding director of the Institute of Biomedical Informatics at Moi University in Kenya. I currently serve as the chair of the Education Working Group for the Pan-Africa Health Informatics Association, and I'm a fellow in the International Academy of Health Sciences Informatics by the International Medical Informatics Association. I've been interested for a long time in capacity building around biomedical informatics in the Africa continent. Currently, I have two projects around capacity building in biomedical informatics. One is the Health Informatics Training and Research in East Africa for improved healthcare. And another one is the Higher Education Partnership for Innovation and Sustainable Biomedical Informatics Capacity in Kenya. When it comes to the issue of capacity building around data sciences, we have a couple of pertinent questions that we really need to ask and also discuss as part of this panel that we'll be having. Is one, how do we systematically capacity build African institutions to take leadership in data sciences and health innovation initiatives? So let's think about that for a moment. And also, who will drive Africa's health data science research and policy agenda? I think most of us, as part of participants in the data sciences symposium, will have received quite the depth of information around what the field is made of, but I'll just go back for reference on what the NIH, National Institutes of Health, defines data science as. So NIH defines data science as the interdisciplinary field of inquiry in which quantitative and analytical approaches, processes, and systems are developed and used to extract knowledge and insights from increasingly large and or complex data sets, okay? Now this obviously includes the collection, storage, integration, analysis of large, heterogeneous, structured and unstructured data sets, and the employment of new computational methods such as deep learning approaches, digital phenotyping, machine learning, artificial intelligence, and 3D imaging, okay? Now, beyond the computational approaches, when you think about data sciences, especially in contexts such as Africa, we also have to think about the ethical, legal, social implications of this work. We have to think about evaluations of the data sciences approaches. And if you add a biomedical component to it, you also have to think about biomedical competencies as part of the capacity building for this project. So it ends up being quite a complex undertaking when you think about how to capacity build on data sciences with a focus on health innovation and biomedical sciences. These are some of the things we hope that as part of the upcoming presentations by members in this panel, we are going to be able to address. Some of the objectives that we hope to bring out as part of the presentations is one, we hope to be able to give a sense of the capacity building approaches in data science that could be employed in the African context. We also hope to discuss issues around quality, competencies, accreditation, alignment with national strategies and sustainability of the data sciences capacity building programs, okay? We will also discuss risks, challenges, and mitigation strategies and how this can be approached when it comes to capacity building initiatives around data sciences in Africa. I know a lot of you will be interested in what networks in capacity building for data sciences exist. And so hopefully those will also be touched on. Now we have some students here and also just individuals who are interested in building their own data sciences competencies, and we will bring up and discuss some of the existing opportunities for capacity building for individuals. And then finally, we hope to use especially the panel discussion part of this initiative to get people to network and to start forming foundations for collaboration around capacity building approaches to health data sciences. We have an excellent group of panelists who will be joining the live session and also who will be presenting as part of this set of panel presentations. I urge you to go to each of the panelists and take a closer look and listen at their presentations. They will have an opportunity to describe the extensive experience, so you'll get that in the individual presentations. And as you listen to the presentations, I also want you to be thinking about what pertinent things or questions you have around capacity building in data sciences and health innovation that will be relevant for us to be thinking about or to bring to the discussion that we hope you'll be able to participate in. If you have a chance, write this down, because at the beginning of the in-person panel discussion, we'll be asking you to share those with us through the online forum. Again, we are excited to have you. Thank you and welcome.
Hello, everyone. My name is Mahadia Tunga. I'm a co-founder and director capacity development at Tanzania dLab in Tanzania, East Africa. So at Tanzania dLab, our main mission is to ensure that data is frequently and effectively used at different levels. So with that, the first thing we normally do in all our capacity building activities is to start with the pain point, understanding what are the core challenges in the ground, because as much as we want to build capacity, but we want that knowledge to be kept into use. So always our first thing is to do an intensive training need assessment to understand what are the data skills gap. Because when we talk about data science, there are different areas that you could train people. But for us, we believe in identifying skill gap and pertinent challenges, and then linking the data science skills to be able to solve such pertinent challenges in the community. So our first step is always training need assessment. And then that always either add a new training area in our curriculum or update our training curriculum. And we normally do that yearly to update our curriculum. So as we are a data lab, so we normally offer two types of training, tailor-made trainings to organizations. And so for organization, that is easy because you just have to identify what is their need so that you can tap into that. And then also we conduct public trainings. That's where you have to understand generally what's the skill gap in the community. But in 2018, 2 years after our existence, we decided to partner with University of Dar es Salaam, designing a Masters in Data Science curriculum. And it was the first curriculum in East Africa. The idea was, as much as we are doing tailor-made programs, we felt that we needed to produce an expert who could actually work in the field, in the organization, and be able to solve challenges. So, and this curriculum is different in such a way that dLab offer support in terms of identifying organization and real world problems where these students could work upon. And most of these problems are health related challenges. So we work with NGOs who are working in health field. So understanding what are their challenges in terms of data, and then students do capstone projects. So, and then we offer them the practicum and connect them to the industry. So the whole idea, as I keep emphasizing, is putting skills into use. So even at the time that they are learning, but ensuring that they're working on the real world problem as opposed to a toy project. And in so doing, so since we are working mostly in health related field, the main challenge that we normally face is organization willing to share data, because it's a confidential data. And so that's the main challenge we have been facing. Currently, we are developing a challenge owner portal where we hope that different organizations could post their challenge so that our students could work on real world challenges. And the other challenge that we face, only less than 1/3 of our participants are female. So, so that's another challenge that that we decided to start an initiative called Data for Her program, which targets university students and early career women who are pursuing their career in tech, or those who at colleges who are taking tech related field, especially data science. And with them, we are training two specific aspects. First, we are training them essential skills, the so-called soft skills, as well as we are identifying what are those emerging skills in technology, be it big data, machine learning, and try to train them and work with the real world problem and attach them with the mentors. The idea is to ensure these few women that are in the tech field to remain in tech. And also those who are at early career position, this program to bridge them into managerial or decision-making position. So our idea is that we just don't want to have women in tech, but rather their position to be felt in their organization. And in so doing, we have also partnered with Institute of Computational and Mathematical Engineering of Stanford University through their Women in Data Science conference initiative, where yearly we conduct Women in Data Science conference, where we gather outstanding women from the field of computer science, the field of data science, who have done real work, and then they share these works with other women, and this helps them to inspire them, but also to understand that it's possible and they can stay in tech. And also we have, in so doing, we have also developed a Women in Tech database to identify these outstanding women so that we can encourage more women into data science field. And COVID has taught us we need to shift the way we are doing. So we are now focusing more on our online learning modules. And we have added more courses in our online modules, so that's to ensure during this unprecedented time, we are staying relevant, and we are keeping right topics, and we are allowing our audience also to leverage the time that they are staying at home. So yeah, so we are doing different other activity in capacity development, but the lesson that I would like to emphasize is to focus on real world problems as we are training these emerging leaders. But also I would want to say that partnerships are key in when we are delivering these capacity building programs, learning from one another and building networks so that we are moving together. With that, I would like to thank you all for listening.
Hello, everyone. My name is Amel Ghoulia. I'm a bioinformatician with a computer sciences background. I spent the last 6 years working for HRA Bionet, which is a bioinformatics capacity building network in Africa. I was based in Tunisia, and I relocated recently to the US, where I started coordinating data science for public health program in Africa, India, and Brazil. And it's a Bill and Melinda Gates program. So today I'm going to share a few experiences in terms of capacity building in bioinformatics and data science that I co-led and have been involved in as part of HRA Bionet and also as part of my new role. So I will start by talking about few bioinformatics training activities that we run as part of HRA Bionet in Africa, some open science activities via which we try to teach reproducible science good practices. And I'm also going to share some alternative learning experiences where we try to build different peer learning environments to teach data science and have people collaborate together to learn data science skills. And I'm going to end by presenting the program I'm helping coordinating now, which is a program for data science to inform public health. So as part of HRA Bionet, I co-led and have been involved in various bioinformatics training activities. These covered a mixture of in-person and online trainings. And the different courses were ranged between very specialized courses and also introductory level courses. We also ran a lot of train the trainer courses where we basically trained people in different regions who were able afterwards to run trainings themselves and sort of keep the ball rolling. So HRA Bionet is a Pan-African bioinformatics network that supports the HRA Africa program, and HRA Africa stands for Human Heredity and Health in Africa. HRA Bionet gathered 28 different nodes across 17 different African countries and was led by Professor Nicola Mulder based at the University of Cape Town. So HRA Bionet aimed at developing a Pan-African bioinformatics structure and also develop bioinformatics capacities in the continent by enabling and enhancing innovative and translational research, and also providing high quality informatics support to different HRA Africa projects. So as mentioned previously, we've run different types of introductory and specialized courses in the continent. A lot of the courses were in-person courses where we basically flew people from all over the continent together in a place and attend the course for a week or longer sometimes. And then we designed an online bioinformatics course. It was an introductory bioinformatics course covering different introductory topics ranging from introduction to Linux, sequence alignments, to an introductory NGS data analysis model. And so this course was a mixture of online and in-person meetings. So what happened is that different classrooms were hosted in the continent, and people who were part of the same who were in the same institution could gather in the virtual classroom, and watch together the lesson, and then they were able to connect with trainers who were who were teaching remotely. But this year, because of the pandemic, everything was 100% virtual, and all attendees connected online. So via these different workshops, we trained over 3,000 people across the continent. And the online trainings allowed to train a much bigger number of students. As part of HA Bionet, we also run different open science activities. So we started some open science trainings. We also ran different roundtable and open cafe discussions, where we basically try to get people together and have discussions around different topics like data sharing, code sharing, preprints, publications, incentives that researchers get by making their work accessible and open. We also launched recently what we called learning circles, and these were very connected to the Introduction to Bioinformatics online course. So we basically encourage every classroom and people who are in the same institution or in the same region to get together after this course and to sort of keep sharing skills among each other. Some chose to have it be like a journal club format. Some others decided to have it be more formal, like they kept teaching each other's different skills. In 2018, we organized an East Africa Open Science Tour. We collaborated with Mozilla Foundation and Sage Bionetworks, and we ran 2 days workshops in 4 different countries in East Africa: Sudan, Ethiopia, Kenya, and Uganda. And we developed a curriculum that we thought we're going to teach in all the 4 different locations, but we found ourselves needing to adjust this curriculum as we go. And we sort of had it be more interactive and adapted to the needs in each locations. So the curriculum basically covered a discussion about the whole research workflow and how we can make the whole research workflow reproducible and why we need to do so. We also spent a lot of time talking about data sharing, code sharing, and incentives. We also covered data management planning and how to make data and all products, all research products fair. We spent a lot of time talking about collaborative research, but we also touched on responsible openness and all the ethical aspects related to data and code sharing. We also covered a lot of the tools and platforms that could be used to enable open science and collaborative research. These are a few pictures from the 4 different courses we ran in East Africa, Uganda, Kenya, Ethiopia, and Sudan. These were very interactive courses and really led to very interesting discussions in the different locations. The next point I'm going to talk about is few what I called here alternative learning experiences. And so as part of HRA Bionet, we organized a lot of hackathons where we basically get people together to try to work on a very specific task for a few days, or sometimes it's a whole week. There were a few hackathons dedicated to bioinformatics workflows development, but I'm going to talk specifically about a hackathon we organized to prepare a dream challenge for malaria drug resistance. So basically, dream challenges are crowdsourcing challenges to design predictive models and pathway inference algorithms. And the aim of what we call the Dream of Malaria hackathon was to prepare a preliminary data set for malaria drug resistance crowdsourcing challenge. And so we created a space for open innovation and learning, and we also gathered scientists from all over Africa. And we partnered with University Notre Dame in the US to sort of organize this challenge. So what happened is that samples were taken from Southeast Asia. Sequencing has been done by University Notre Dame in the US, and then we brought this data to Africa and gathered scientists in Johannesburg, South We where they worked together for a whole week to prepare this data set for the Dream Challenge. But before we were able to gather in South Africa, what we did is that after the data has been generated, we organized a lot of online meetings where we basically got all the selected hackathon participants get together online and form teams and decide about a work plan they're going to follow during the whole hackathon meeting. And obviously they had to adjust their plans as we go during the hackathon. But it was really very good to sort of build teams and start preparing the work so that when we gathered in September 2016 in South Africa, all the teams were ready to get their hands in the data. After the whole week hackathon, we also continued meeting online to sort of wrap up the data analysis that led to a final preparation of the data set and a launch of the Dream Challenge in 2019. This is a group picture of all the hackathon attendees. These were data scientists, biostatisticians, biologists, and malaria experts that were at very different career stages. So we all gathered at IBM Research South Africa for a whole week. And one thing worth mentioning here is that when we formed teams, we also thought a lot about backgrounds and skills, but also different career stages. So teams were formed by PhD students, senior PIs, people who were malaria experts, data scientists from IBM Research, and it's really created a very good learning experience. And at the end of the hackathon, we sort of tried to do a skills gain assessment, and it was really very good to see that it was a very good peer learning exercise. So as I mentioned, the Dream of Malaria challenge was launched for the global community in 2019, and a lot of African teams were able to participate to this global challenge. Last but not least, I'm going to talk very quickly about the data science program I helped coordinating to inform public health in different regions. So it's basically a data-focused grant challenge run by the Knowledge Integration Team based at the Bill and Melinda Gates Foundation. And it's a program aiming at answering different questions using data to improve maternal and child health in Brazil, Africa, and India. So basically this program aimed to build a knowledge base from existing research data, then apply different methods, different data science methods to try to answer questions using these data resources. And then results obtained are used to help informing decisions and help informing policies to improve maternal and child health in the different regions. So the KIGC program basically aims at building a global collaboration between PIs and data scientists And they we really seek here enabling data scientists to collaborate with different researchers working on MNCH. This program also offers a lot of career opportunities for data scientists who are willing to work on global health and willing to use their data science skills to impact global health and to sort of answer global health problems very quickly and efficiently. And the third aim of the KIGCs is to also identify available data sources that are of a very high value for solving MNCH through data problems. So the ultimate goal of these KIGC programs is also to create a platform in which data scientists collaborate with public health experts, where they can share data, tools, and expertise to sort of solve very quickly and deeply some of the public health issues and help improving and saving lives. And I'll end by acknowledging my former HRA Bionet colleagues and Thea Norman from the Bill and Melinda Gates Foundation and all quantitative science and knowledge integration team members and other collaborators, including Mozilla Foundation, Sage Bionetwork, University of Notre Dame, IBM Research, Dream Challenges Community, and African Academy of Sciences. Thank you.
Hello, everyone. It's a great honor and privilege to share with you the AFSIN experience in the context of the NIH Symposium on training the next generation of leaders in data science and health innovation. AFSIN is an acronym for African Spectral Imaging Network. Let me introduce myself. I'm Jeremie Zoueu. I'm full professor of photonics at the National Polytechnic Institute in Yamoussoukro in Ivory Coast. I'm also the coordinator of AFSIN, the Spectral Imaging Network. I'm the first vice president of the Ivorian Physical Society, and I belong to the Scientific Council of a number of national and international scientific committees. Through AFSIN initiatives, African physicists are developing and reinforcing African research capacities. AFSIN scientists are training the next generation of scientists in interdisciplinary area of engineering. And we are applying the technologies of optical spectroscopy to biomedical, agriculture, and environmental projects. A small group of physicists from 4 countries created AFSIN in Dakar in 2010. And that group has grown to include 8 countries today. Several additional countries are knocking on AFSIN door. The effort is supported financially by Uppsala University and technically by Lund University, both from Sweden. Over the past 10 years, AFSIN helped to equip 6 research laboratories and to train more than 100 master students and 30 PhD students from across the African continent, specifically in the area of biomedical optics. We have also designed and constructed biomedical diagnosis tools to tackle a number of tropical diseases, such as malaria and Borrelia ulcer. The distinguishing characteristic of these type of equipments involve the ability to combine both data science, AI, machine learning, and optical science and technologies, something that has demonstrated its potential to solve a number of developing countries' issues. But how do we get there? Let me introduce my own trajectory. I grew in Ivory Coast in West Africa, where I studied in both Yamoussoukro and Abidjan. After earning my bachelor degree, I moved to Paris in France and earned a master's degree in physics in 1992 at Galilei Institute. At Pierre-Marie Curie University, I went to earn my PhD in 1996. After spending several months doing postdoctoral research in Paris, I turned down opportunities to establish a career in France and returned home to pursue a career in higher education in my native Ivory Coast. I found it rewarding to educate the next generation of African scientists in science and technology, despite the opportunities that were available if I had chosen to pursue a career in Europe. It was a challenging decision experience because there was no office of grants and contracts, and there were no startup found to establish a research lab. I had to build my research lab from scratch. I also had to pay from my salary the research equipment, travel to conference, to pay article publication fees, as my institution did not provide funding for that. In addition to that, a personal family experience led me to change my initial area of research. I came to focus on biomedical engineering research and applied physics after my daughter fell ill with malaria. The hospital did a blood smear test, which is currently the gold standard to diagnose malaria, but they were not able to confirm whether it was malaria or not. After my daughter fell into a coma, we drove her to another city 3 hours away, where a bigger hospital with better research facilities was able to provide an accurate diagnosis and to help cure my little girl. It was then that I started learning more about biomedical engineering and wanted to help other families to avoid this type of situation in the future by making it possible to have fast and accurate malaria diagnosis facilities in all hospitals. This experience shaped my new research orientation from a background of fundamental research in laser engineering to biophotonic to interdisciplinary biomedical research. Now, in addition to my involvement with AFSIN, I am also leading a master's degree training in biomedical engineering at the National Polytechnic Institute. And I am the project director of VCU Medicine for All initiative in West Africa. My own trajectory, like that of other African scientists, has led me to reflect on how we can use our scientific backgrounds to assist communities in their fight against diseases and hunger. This led me to the creation of AFSIN. Our goal are to do high-level science to identify and train talented students and to apply our scientific expertise and experience to various societal concerns, including public health issues. Generally, once a year, we bring together students and younger staff members in one of the participating countries for training in scientific workshops. During these workshops, we usually build an instrument, and after the workshop, that instrument is used for both research and problem solving in the student's home country. In addition to the pride it instills in the student, an added advantage is that having an instrument constructed by the student themselves enables them to handle instrument maintenance with ease. How does all this work? The board reflects on the social problem to deal with that. For that here, we then work on the best scientific solution to address the problem, which should also provide opportunities to acquire scientific knowledge and technical skills. There are always part of the session focusing on data science and analysis, and specifically on chemometrics and machine learning. We invite application from the best lecturers across the world with the collaboration and assistance of OSA, the Optical Society of America, and SPI, the International Society for Optics and Photonics. Usually they found one lecturer, both airfare and living expenses. The schedule is laid out in such a way that part of the time is dedicated to a practical session, data analysis, and competition among the students. On average, the workshop lasts 10 to 14 days. Because of the current pandemic, we are now developing more intensively both online training and use facilities that were used for the various other activities in the past. What do we learn from this experience? We were able to keep the students in Africa and share with them the ideal of developing a local capacity with international standard to solve important local issues in developing countries. We were able to provide a competitive and attractive environment to the students for their research. We were able to provide international recognition through the framework of joint thesis supervision and co-direction with some international scientific partners. We have demonstrated how to tackle African health problems with African scientists who are able to include the social and cultural aspects in the solution they provided. Our goal now is to expand the number of our scientific and financial support partners in order to include more African countries and extend our experience and capacities to more diverse health problems. Thank you very much for your attention.
Hello, everyone. I'm Ignace Kabano. I'm the head of training at the African Center of Excellence in Data Science, and I'm the senior lecturer of demography and statistics from the Department of Applied Statistics, University of Rwanda. It's a pleasure to be part of this panel discussing the prospects of the data science development in Africa with the support of NIH. And I'm going to present on the need for data science in Africa, the current status and prospects. My presentation is going to follow, to go through the following milestone. I'll have to introduce myself, and then match data science with the need for data science in the Sustainable Development Goals. And then I will talk about the role of big data analytics for development and the need for data science in Africa, and then challenges, current challenges and strategies, and then conclusion and way forward. I'm Ignace Abimana Kabano. My background, I'm trained as a demographer, both in my master's and PhD, respectively, from Groningen University and Utrecht University in the Netherlands. I'm currently a senior lecturer of demography and statistics in the Department of Applied Statistics, and I'm one of the pioneers and head of training of the African Center of Excellence in Data Science, University of Rwanda. I'm a steering committee member of the Data Revolution Policy through the National Institute of Statistics of Rwanda. and I'm the focal person of the Global Partnership for Sustainable Development Data. I'm a member of the Demographic Dividend Chapter in preparation of the 2021 International Conference on Family Planning. Data science being a combination of various tools and machine learning principles to discover hidden patterns of raw data, big, structured or unstructured, or to predict the events or phenomenon is highly useful for policymakers, health practitioners, business practitioners, as well as planners and data scientists are highly needed in this to predict and to play a role in the analysis and planning of the Sustainable Development Goals. The data science uses big data. As you can see on the screen, it has data, it gathers data from mobile phones, from financial transaction, from transportation, online, and social media, crowdsourced online content, physical, remote, and so on. Africa highly needs data scientists as a country which is, as a continent which is striving to catch up with the delay in development, and therefore, being in a rising continent, it needs to catalyze innovation in business analytics, health care and health analytics, health research, and through the use of data science predictive algorithm and application. Academic institutions in this continent are on the rise, creating platform and collaborative partnerships in fostering data science training to stimulate research and capacity building in data science subject. Some of these institutions include the African Center of Excellence in Data Science from the University of Rwanda, the School for Data Science and Computational Training from Stellenbosch University, South Africa, the Artificial Intelligence and Machine Learning Science Group from Makerere University, the Data Analytics from the University of KwaZulu-Natal, the dLab from the Tanzania University of Dar es Salaam, and so many others. And the thirst for Africans to excel in data science is currently high, and this is observed in big numbers of enrollment in all data science teaching institutions across Africa. Since 2018, the African Center, for instance, in data science of the University of Rwanda has registered a big number of applicants in masters. Currently, we have more than 72 candidates, and we have more than 38 candidates in PhD in all specializations. Noting that data science being a multidisciplinary domain, we train data scientists first to have common modules that are training candidates in data mining techniques, but then at the end, they can apply this in health and biostatistics, in demography, in econometrics, in actuarial sciences, and so on. Aside from nationals, enrolled students come from a number of countries, including Kenya, Uganda, Tanzania, Burundi, DRC, Ethiopia, Zambia, Equatorial Guinea, Cameroon, Zimbabwe, Comoros, Central African Republic, and so on, thus covering a number of African countries. Data science being a blend of mathematics, statistics, and computer science, most lecturers have expertise in one of these fields, which is actually a challenge, while a need exists to have fully equipped data scientists who encounter or who are equipped in both IT skills relating to data manipulation and data capture, but also to statistical and mathematical capability of analyzing these big data. And the next challenge is, for instance, particularly for the African Center of Excellence in Data Science of Rwanda, when it comes to diversifying application areas like health data analytics, biostatistics, demography, actuarial, and econometrics, for which sometimes we outsource expertise from other higher learning institutions, either in Africa, USA, namely the Harvard Data Science Initiative, the Rochester Institute of Technology and Rochester University, UK or Europe. The second challenges are related to accessibility and use of big data. Actually, accessibility and use of these big data require the adoption of data revolution policies by African countries. And few countries so far have adopted this policy, and the creation of ample collaboration platform between data generators and the data users is very useful. So the data revolution policy in African countries would actually favor or create a platform through which the data producers, I want to name some few, like telecommunication companies or other manufacturing companies and others which have very big data, to have a will to create a platform through which a collaboration can exist between these data providers or producers, owners, and the data users. They can have a common understanding on how to use the data in a way that it doesn't hamper the business objectives of these data generators, or either create just a bias in terms of competitiveness between these different institutions once data can be shared or given or presented by a researcher without any protective mechanism. So the sustainability also of the data science program require to secure more funding and to put in place a collaboration and partnership frameworks among African higher learning institutions that run data science programs. But also, on the other hand, that collaboration and partnership is supposed to be also developed between African higher learning institutions and other institutions abroad outside the African continent. And to conclude, data science is highly needed in Africa to grow the body of knowledge through contextual research, develop and implement programs for providing trainings in areas of big data, data analytics, machine learning, and artificial intelligence in order to grow the number of skills in these new and rapidly growing fields of study. More funding and partnership strengthening will highly contribute to the sustainability in the education of data scientists in Africa. Thank you very much.